movie, we use this exam question to remind ourselves about the meanings of positional and functional isomers and how to give IUPAC names, structural and molecular formulae. If you missed the previous movie about the previous sub-question of the same exam question, click here. Organic isomers are two or more organic compounds, notice, not one compound, two or more organic compounds which have something in common and something out of common between them. What is in common between the members of an organic isomer? They all have the same molecular formula. What is different between the individual isomers? That depends on what type of isomer it is. If it's a functional isomer, then the individuals have different functional groups. If it's a positional isomer, then they have the same functional group, but where that functional group is positioned is different between the different isomers. Now let's look at this particular compound. We can see that it has a carbonyl group, so it's either a ketone or an aldehyde. Click here for more practice about naming ketones and aldehydes. Now, how do you tell the difference between them? It depends upon where that carbonyl group is. Is it at the end? Then it's an aldehyde. Is it within? Then it's a ketone. So in this case, it's a ketone. How many carbons are there? 5. But we also have to mention the number of the carbon where we have that functional group. We see that the functional group is on carbon 2, so it's pentan 2-one. The molecular formula of pentan 2-one is C5H10O. So all the isomers, whether they be positional or functional, of pentan 2-one have to have the same molecular formula. The positional isomer of this compound must still be a ketone, so that carbonyl group still needs to be within the carbon chain, not at the end. So here we have pentan 2-one, and for the positional isomer, there's only one place where that carbonyl group can be, and that is on position 3. Notice that if it was over here on carbon 4, that would actually then be the same as this. It would also be pentan 2-one. Why? Because then we would have started numbering from this end. 1, 2. Obviously here we still need to add in the hydrogen atoms. No hydrogen atoms bonded to this carbon because it already has 1, 2, 3, 4 bonds. Notice this has the same molecular formula as pentan 2-one, 5 carbons and 10 hydrogens and 1 oxygen, C5H10O. What would its name be? Again, it would be pentan something-one, but now it would be pentan 3-one. The functional isomer of pentan 2-one must not be a ketone. So it has to be an aldehyde, because only an aldehyde could still have the same molecular structure as a ketone. So now the carbonyl group needs to be at the end. It doesn't matter whether we put this carbonyl group at this end or at this end, because whichever end we place it, we'll start counting from there. We fill in the hydrogens so that each carbon has 4 bonds. And we see that again, the molecular formula is C5H10O. And what about the name? Pentan, but now L for aldehyde. And there's no need to write a number here, unlike in the case of the ketone, because it has to be at the end. So, of course, after you've made sense of the question, as we have just done, you do need to look at what you were actually asked and make sure that you answer what you were asked. And you weren't asked to give the structural formulae and the IUPAC names for both the positional and functional isomers. Instead, you were simply asked to give this one, the IUPAC name of the positional isomer, pentan-3-one, and the structural formula of the functional isomer. And here's a question for you to answer in the comment section below. How many positional isomers does hexan-2-one have, and what are their names? And what about functional isomers of hexan-2-one? Make sure to watch the next movie answering the next sub-question of this exam question. And you can also download the entire question from the link below. Don't forget also to like and to subscribe.